example problems. Give you a head start, and I'm catching up. So here's the first.
Oh my God. Yeah.
Hopefully you've started this. If you're slacking on that, don't do that part. Okay. Which side does 7 meters a second go in? Hopefully you said neither horizontal or vertical. So if you put 7 on one of these sides, erase it and know that that was sudden death. But do you understand why it's sudden death? It's not going horizontal, nor is it going vertical. Okay? So your first step is to find these two sides. If you did not get those sides, pay attention to what I'm about to say. If you did get those sides, continue on. So I'm given the hypotenuse of this triangle and I'm given the angle. I'm looking for the adjacent side and the opposite side. So I always want to use the hypotenuse because I'm given that. I might have messed up if I used one of those two sides. So the x, I'm going to use cosine found that to be 5.36. And in the y direction, that's opposite. So I'm going to use sine 40. Okay. Now, the follow-up question to that is, okay, great, I got those numbers, but what are those? What do you do with them? Okay. To answer that, part of the way to answer that, whatever that unit is, that has to be the same units for all sides of the triangle. So, pop quiz. Is this the height? Is this how high it went? Height would be measured in what? Meters. You have meters per second. So what this tells us is our initial horizontal velocity is 5.36 meters per second. Our initial vertical velocity is 4.5 meters per second. Okay, good with that. These are not distances, these are velocities. Okay, so can carry on.
I solved it two different ways because I felt like it was weird that was 0. So I got different answers. They're like kind of similar, but like different. So I don't know what I did wrong. It was like an answer.
Are you looking for your height? How high did it go?
I don't even remember, to be honest. I have the thing right here. It's
You bring it down from.
it's how far above. Yeah. So I think I did that one first.
Okay. Where is it when the velocity, vertical velocity is negative 1.23? Sorry, negative 1.23. Where is it located in the trajectory?
I don't know. I'm confused.
When does it have the negative?
Did I do all of it wrong?
No, just hold on. When does it have the negative of what it started?
I don't know what you're asking, to be honest. My brain's like.
Okay, so the water's doing this.
Mm-hmm. Yeah.
Here it's going 1.23 meters a second up.
Mm-hmm. Oh, so it does. So it's not. Wait.
When is it moving this speed downward?
When it's like downward here.
Right. We're looking for it when. Where's the water?
At the highest. Oh, so the initial or the final would be 0?
Right.
Okay.
Yep.
But would that be the answer?
What?
Wait, so
the
will
reason
everything
why,
else be right if I change that?
Yeah, the reason why this is 0 is because it's back down to where it started. So this should be 0. When you multiply by 0, that should be 0.
Oh, I thought that just.
You multiplied by 0.
The whole answer is 0.
It would be,
Okay,
but
thank you.
that's not. Okay. If we make this our final, you got acceleration, vertical acceleration negative 9.8. You make your final vertical velocity negative 4.5 meters a second. You make your final horizontal velocity 5.36. If you wanted to lump this together, tell your neighbor why these are the same. If you wanted to say just horizontal velocity is 5.36, totally fine with that. Okay. If you wanted to say acceleration in the horizontal direction is equal to 0, you could do that as well. We're looking for delta x. Okay. Personally, this is just my preference. If I'm looking for something in a horizontal direction, I know it's moving at a constant velocity. So I'm going to use the constant velocity equation. But my problem is I don't have time. Time, however, is the single variable that can dance between horizontal and vertical because time doesn't have direction. Time isn't just going horizontal. It isn't just vertical, like it doesn't have, okay? The ball is moving horizontally and vertically simultaneously. So you need to figure out time. Your kinematic equations. You're welcome. That was requested earlier today. No. So we find time to be equal to 0.92. Now beat me across the finish line. Just by yourself. Question?
Yeah. Okay. 918.
Mm-hmm.
Like, would you still count that wrong, even though this could be like slightly off?
No, that's totally fine.
Okay.
Yep. So I'm going to use 5.36. Oops. Times 0.92. And I find that to be 4.9 meters. Okay. Good with that. How do we do? Quick confidence vote. Could you do this independently? 5 rocking it out. 1 like. Flash me a quick digit here. Where you at? Okay. Big picture. Ready? If you're at a place where you're not comfortable, big picture. Set it up. Variables in the chart. Don't slack on that. Okay. This cannot, 7 meters a second, cannot go into one of these two sides. So the way we deal with that is we break it up into components. That's the whole point. This is how fast it's going horizontally. This is how fast it's going vertically at the beginning. Okay. Then to fill in the rest of the variables, you're using fund factor free fall and the idea that there's constant velocity in the horizontal direction. Okay. Find time. Use time that can dance between the two sides to figure out your missing variable. Big picture. Okay. Follow-up question. Same scenario, same toddler. Go. Okay. I'm going to initial spot here. I'm still going to do the triangle. Okay. So we're just recycling stuff just to like save time. But I'm going to make my final spot here. at the highest point. Think what happens, don't say it out loud, what happens at the highest point. You're going to make your final vertical velocity 0. And you're looking for delta y. Okay, I'm kind of running out of room here. But I'm going to choose the most direct path. My opinion is this. Okay. I got 1.03. How do we do? Good there? Now, if you wanted to incorporate the time, where was the ball at 0.92 seconds? The ball is right here. So if you wanted to incorporate the time that we found from the previous, that's fine. How much time would it be? 0.46 seconds. Why? Time up equals the time down. You all right with that? You gotta think like, Okay. How we doing? All right. Good with that? Okay, here's a conceptual question. Tell your neighbor.
It's just a ball. Just like a ball. Like a ball. Oh. It's just a ball. But it seems like there's a ball. No. I feel like yes. I feel like
So when I say overall, I'm talking about horizontal and vertical.
I think oh yeah, because there's it's speed. That's horizontal speed. Horizontal speed is vertical speed. I think it is. It is what's that? I just figured it out because you're here. But on number 4, it says how fast did he jump, but it doesn't matter how fast he jumps. I feel like because if he's jumping like to the side, he's just gonna like fall anyways. I don't like get what it's asking.
Could he jump slow enough that he misses it? Can he jump fast enough that he goes over it?
How do you figure that out then? I don't know what that means.
So set it up.
So you would define is it just solving for initial velocity for horizontal? Like that's it? Okay. Thank you.
Welcome. Correct answer is the one that was thrown. How do the vertical velocities compare? Both have the same vertical velocities. But the one that was thrown also has horizontal velocity. Give that one a shot. You're going to miss this problem. Here's 75% of the reason why. Because you forgot that when something is launched horizontally, thrown, kicked, whatever, horizontally, how fast is it going up or down initially? It's not. Okay. I'm looking for those two things. Final horizontal velocity and final vertical velocity. Conceptually, this is still just 6 meters a second. I need to solve this. Okay. When I take the square root of this, I need it's plus or minus. I'm choosing minus because it's moving down. So beat me to the finish line. At the end here, it's moving 6 meters a second horizontally and 14 meters per second vertically. I need to find the resultant. So I copy and paste. Now that's 14 meters a second. So the resultant Pythagorean theorem is 15 something. 0.2. A squared plus B squared equals C squared. How do you do? Good with that?